This is Algebra 2, Unit 5, Lesson 2, the rest of the notes on arithmetic and geometric sequences. Okay, so just to review, an arithmetic sequence is a sequence that goes up by adding. Its general form is a of n equals a1 plus n minus 1 times d. Remember, d is the common difference. That's what it goes up or down by, adding or subtracting. All right, this is the common difference. And whatever sequence term that you are on here, this one will always be one less than that. So you have to start at your first term of your sequence, and you are going to add however many one less than the term number you're on that many times to get the common difference. Okay, so to use that, let's do exercise 4. Given that a1 equals 6 and a4 equals 18 are members of an arithmetic sequence, determine the value of a20. Okay, so to figure out a20, the 20th term of the sequence, we have to start at the first term, a1, and we are going to add something, whatever it happens to be, n minus 1 times. Well, how many times, if we start on the first term, are we going to have to add something to get to the 20th term? It would have to be 19. So if this is n minus 1, this is going to be 19 times whatever d is. And we're starting from the first term, which in this case is going to be 6. So we're going to start at 6, and we're going to add something 19 times to get the 20th term. Okay, now the problem is we don't know what we're adding. So we're going to use these two factors, or these two sequence terms, to figure it out. All right, let's think about this. We know this is the first term of the sequence is 6. This is the second term, third term, and then the fourth term is 18. Okay, so if we're starting at 6, how many times are we going to add something to get to the fourth term? We're going to add something 3 times, whatever that happens to be, we're going to add it 3 times to get to the fourth term, and we'll end up at the value of 18. Well, if we do that, if we add d here, add d here, add d here, because it's all the same, we're adding 3 d's to get to 18, starting from 6. All right, let's solve this for d. Subtract the 6. 3d equals 12. Divide by 3, and that means that d is equal to 4. Okay, so that means we are going to add 4 each time when we do this. So if I add 4 here, let's make sure this works. This is going to be 10. Add 4 here, that makes this 14, and add 4 is going to be 18. So that's the correct d. So to figure out the 20th term of the sequence, we have to start at 6, and we are going to add add 4 19 times. All right, I usually put the d in front of the values, but that's where it happens to come out. So 6 plus 19 times 4 is 82. So if I were to go up by 4 every time and got to the 20th term will be 82. Okay, so the trick to doing an arithmetic sequence, you are adding something one less time than the first term, because you're starting on the first term. Okay, so first term plus whatever you're adding, subtracting, one less than whatever this number is right there. Okay, so that's an arithmetic sequence. Now we're going to talk about geometric sequences. Okay, you may remember from Algebra 1 that an arithmetic sequence is going up by increasing by adding or subtracting. A geometric sequence is going up by multiplying. This is by multiplying or dividing. Usually we say multiplying because it's easier to say. All right, so if we are given f of 1, and then the rule is fn minus 1 times r, or a of n minus 1 times r. Basically what you're doing is you're taking the previous term and multiplying it by something. That is called, the r is called the common ratio. It's what you multiply by. Now it can be positive or negative, or it can be fractional. It's what you multiply by. Okay, so if I want to generate the next 3 terms of the geometric sequence, a1 equals 4 and r equals 2, this means I'm going to multiply by each previous term by 2. So if a1 is equal to 4, a2 is going to be the previous term 4 times 2, which would be 8. a3 would be the previous term, which would be 8, times 2 is 16. And then a4 would be the previous term, which in this case would be a3, times 2 would be 32. So notice here, if I'm starting at 4, my sequence starts at 4, 8, 16, 32. I am doubling each time. I'm multiplying by 2 because that's the common ratio. Okay, so this one says f of n equals f of n minus 1 times a third. So this means take the previous term and multiply by a third, and f of 1 is equal to 9. So if f of 1 equals 9, the first term is 9, what are we going to do each time? We're going to take the previous term multiplied by a third. So 9 times a third would be 3. All right, the third term, take the previous term, in this case the second term, multiply it by a third, will equal 1. And then the fourth term of the sequence, take the previous term, which is 1, multiply it by a third, will give me a third. So that means my sequence is going 9, 3, 1, 1/3, dot, dot, dot. So notice, because the multiplier is a fraction, what is your sequence doing? It is decreasing. Okay, so let's look at letter C. T of n equals t of n minus 1 times the square root of 2, with t1 equals 3 square root of 2. Okay, so my first term of my sequence is going to be 3 times the square root of 2. All right, my second term of the sequence, I'm going to take the previous term, that's just another notation, and multiply by the square root of 2. So take the previous term, 3 square root of 2, and I'm going to multiply it by the square root of 2. Square root of 2 times square root of 2 is just going to be 2, so this is going to be 3 times 2, which is 6. All right, t of 3, take the previous term 6, multiply it by the square root of 2, gives me 6 times the square root of 2. Okay, and then the fourth term of the sequence, I take the previous term, 6 square root of 2, and I multiply it by the square root of 2, because that's what it says to do, multiply the previous term. Square root of 2 times square root of 2 is just 2, so this is going to be 6 times 2 is going to be 12. So there you go. So a geometric sequence means you multiply the previous term by a value. Okay, now like arithmetic, we also need to be able to determine any given term of a geometric sequence based on the first value, the common ratio, and the index. All right, so if we have this exercise, consider a1 equals 2, a of n equals a of n minus 1 times 3. All right, so I need to generate the value of a of 4. So I need to know all the terms before a of 4 to figure out what its term is based on this. I know my first term is 2. My second term, remember this means previous term, so take the previous term and do what with it? Multiply it by 3. So my second term of my sequence is going to be 6. To find the third term, take the previous term, which is 6, multiply it by 3, which is 18. And then a of 4 would be the previous term, 18, multiplied by 3 is 54. So if you have a recursive sequence, you have to know the previous term before you can move on to the next term. All right, now let's think about this for a second. How many times did you need to multiply 2 by 3 in order to find a4? All right, so we started at 2 was the first term. We multiplied by 3 for the second term and got 6. We multiplied by 3 again. We got 18. And then we multiplied by 3 again to get the fourth term, which would be 54. So how many times did I multiply by 3? You had to multiply it by 3 times. So we started at 2. We multiplied by 3 a total of 3 times. Isn't that an exponent? Yeah. So that would be 3 times, the third is 27. Times 2 is going to be 54. So that's how we did it. We did the first term times the multiplier, a total of 3 times because we went from the first term to the fourth term. Okay, so let's use that rule to figure out the value of A10. Okay, what number did we start with in our sequence? We started the first term, which is 2. Then we are going to multiply by what number every time? We're going to multiply by 3. Now, if we're starting at the first term, going to the 10th term, how many times are we going to multiply by 3? We're actually going to multiply by 3 9 times, so it's always going to be 1 less than the term number, because we're starting at 1, the first term, instead of the 0 term. So that's always going to be 1 less than the term number when we do that. So when we work this out, 2 times 3 to the 9th, let me grab my calculator. All right, 2 times 3 raised to the 9th, and I get 39,366. So the 10th term of this sequence will be 39,366. Okay, that's a lot easier than having to do the 9 previous terms on that, to do that. So you just have to figure out the rule. So if we write a formula for the nth term of a geometric sequence, a of n, based on the first term, a1, r, and n. Well, let's think about what we just did. Any term of the sequence, we always started at, for any term of the sequence, we started at the first term. Then we multiplied by something. That is r. That's your common ratio. And how many times are we going to multiply by r? We're going to multiply it 1 less than whatever this term is right here. So, because we're starting at the first term, to whatever term we end up with, this is going to be an exponent of n minus 1. So this is a of n is equal to a1 times r to the n minus 1. That's the formula for a geometric sequence. Okay, so to wrap it up, an arithmetic sequence, you start at the first term and you add something which is called the common difference, however, 1 less time than you end up at the next term number. For a geometric sequence, you do the same thing except you have to multiply instead of add, and it's always 1 less time that you do that. Okay, so that's about arithmetic and geometric sequences. You can start the homework as you wish.